Good morning, everyone. And we will start today with another keynote from Per Öster from CSC Finland. And Per is a director of CSC Advanced Computing Facility, which operates and develops the Finnish national computing infrastructure and hosts the EuroHPC pre-exascale system LUMI. And during his talk, he will tell about the LUMI, the unique unique HPC ecosystem. I will let him tell more himself. I think no further introductions are needed. So the floor is yours.
Thank you. I jump up on this beautiful stage here. So, there's the clicker. Let's hope it works. So, thank you for the invitation and this opportunity to tell a bit about LUMI. Sometimes I hear complaints that it's LUMI everywhere, and but I don't take it as a complaint. I take it, yeah, we are successful. That's how it should be. Just checking that you see what I see, and then everything is fine. Yes. So I will talk a bit about LUMI and give a feeling for when we say that it's an ecosystem. Biologists or zoologists, they don't like when we use this term, but just to describe how many things, something gets started and many things around it comes with it, and a lot of dependencies appears, and a lot of good things is happening. So just to give you a feeling for this in one slide, maybe this is the only slide I would have needed for this talk, but it's a bit messy, but I try to explain it. So for us, LUMI started almost more than 10 years ago in a way, because in 2012 we made the final decision to move our data center to this old paper industry in the middle of Finland. And the reason for that, we have our offices in the center in Espoo. It's just outside Helsinki, and it is a, let's say, office area. Nokia used to have their headquarters in the same area and so on. And when we needed to expand our data center there, it was not feasible simply because the cost of doing it was skyrocketing. So then we but at the same time we had for quite some time also been active in various movements here towards European HPC systems. Some of you are familiar with projects like DESA, later PRAISE. There have been committees looking into common European investments and so on. So we have a feeling that at some point there will be large common European systems. And we didn't spell it out loud, but this was also in the thoughts. Why shouldn't we, in our next data center, be in a place where we really can expand if we get the chance? So this was also behind the choice of this kind of place, where the paper industry is a heavy energy consumption. People are complaining today about data center, they are using so much energy. The paper industry here, they had an energy consumption of 280 megawatts. So we would use less than 5% or something of that in the beginning, or even less. Yeah? Well, our first implementation here was a 2 megawatt data center. With the paper industry, it was also local infrastructure there, with local production, hydroelectric energy, 3 power stations. There was also a burning bioenergy plant, and there was sufficient with water if you needed cold water, cooling or whatever. And the climate is very favorable also for free cooling. So eventually we went there. We put our national facility there, and it worked very well. So when the opportunity came and our government was got interested also, when European machines actually started to become reality, we together, or really with the Ministry of Education, started to look into the option of actually bidding for one of these machines. And the way to do that with a small country is, of course, it's big money. So if you can form a consortium of several countries, that could be realized. And that is what we have done, and it resulted in LUMI, the machine that you know there. And the consortium you see over here, with all, starting of course with the European Commission and the joint undertaking, but all the 11 countries that are now part of this consortium. And that, I would say, is then the basic of an ecosystem, because it means that this system, why is LUMI everywhere? Because it is everywhere. At least in a lot of number of countries. Every country that are part of the consortium, there is of course an ambassador of usage of these systems and usage of HPC and bringing HPC to research and industry in large scale. Yeah? So it become much more focus on it and much more widespread instead of it's just one country that, so to say, owns and focus on the system. Of course, the European systems, they are for all researchers in Europe and all for all industry. But if you have really ambassadors in each of the countries, that makes a difference, how it is really taken up and used. So also how LUMI has evolved. I mean, the ecosystem continues also with other technology. We were looking into quantum computing and, well, analyzing this and say, okay, what will quantum computing? It's not in practical use yet for much, but if it will be an accelerator for HPC. So if we can get the users of our large machines start to think about quantum computing and start to wonder what they can do with it, then they will be ready when it's really ready for making use of. So what we have done is that we have connected quantum computers. 2 of them have been connected to, right now it's just one that is directly in use, and that's the Finnish one. And procurement is ongoing now by the joint undertaking for a LUMI queue that will be placed in the Czech Republic. That also will be connected. And that starts, and I think we have about 10 projects in there, but I will come back to that. Rest of the ecosystem is, of course, all the different scientific use. Yeah? All different areas that are making use of the large-scale computing now. And that is, so to say, the basic thing that everybody expected and what we built it for, but also the other community here in industry, where it is much more footwork, so to say, that have to be done to really deploy and find those industries that can make use of it, that want to make use of it, and can take the opportunity and see that they can take a next step in their development with their products and with their business if they get access to these kind of systems. And we saw very nice presentations yesterday about how this work has been going on for many decades, I would say, in Germany, and it is not a simple task, yeah? But it is a very rewarding task, and that is also, so to say, well, I would say a very important fact if we are going to justify these big investments. Because like any other research infrastructure, it need to be there it is there for a general benefit of society. You can't just focus on one thing, the most advanced and excellent research. You have to focus also on, you have to have in mind also the general benefits for society here in terms of industry and business benefits. Okay, all these things together form an ecosystem, and that is a large number of activities. I must mention one more thing. How do you get access to this system? Yes, you can. There are in each of the countries here that have invested directly in the system, you can apply for time on the system, yeah? And that's handled individually by each of the countries, and they have did slightly different policies, but that's up to each of us. And some of us are focusing both on industry and research. Others are focusing mostly on research and so on. But that's absolutely okay. But for all European researchers and industry, the EuroHPC joint undertakings access process is there. So that even also for researchers from all these consortium countries. So one have to remember this. There are several ways into the system. Okay, say something about the actual system, LUMI. This is what it looks like in the data center. It's a HPE Cray EX supercomputer, and I bring this up also to say a bit that it's not a walk in the park to run any of these systems. When they get this large, when they get this complex, and when you have procured the latest, greatest technology that is, so to say, not put in, tested in production, and not until it's delivered. And LUMI here, we had the technology there. At the same time as LUMI was installed, the Frontier, which is now the #1 in the world, with the first exascale machine, same technology, was installed in Oak Ridge Department of Energy laboratory in the US. And so, and I can't go into details, but I mean, the vendor, they discover things during the installation of the system that, okay, we have to do this instead and not follow what we discovered in our own lab, in our own test systems and so on. So there are changes in the system while they are installed even. And you have pushed technology here to to the limit. And in that sense also to talk about supercomputers for those who are not users of it or common, it is like a Formula 1 car in that sense, that yes, when they work they go very fast, but as you know, they even the best drivers, they don't complete some of the races because the technology is not with them, yeah. But that is the, so to say, the pain you have to pay a bit for really being there in the forefront. And I also want to emphasize that these large machines, they are like large research infrastructures in general, yeah. And we have huge investments in cyclotrons, extreme lasers, and so on around Europe through the ESFRI process. And computing is done in a different way, but I think that through the joint undertaking, we have got a similar process for really getting there and also getting access in Europe to these very large systems. So, but because what have happened very much before is that the most excellent research, they have found this type of research infrastructure abroad, in the US typically, or in Japan. And the best ones, they have been allowed to use those systems, but that's only a few researchers that have had from Europe that have access to this. But now we have a more general access. And with these supercomputers, I mean, they work like scientific. We can go into the most microcosmos things to the large looking into the astronomy cases. So it spans all areas of research really. And now computer science even have been huge user of this system through the whole AI and large language models work that is going on. So I don't know if this is an AI generated picture of a time machine, but the supercomputers also works like time machines. I mean, we can study things, what's happening in climate, for example, what we could predict about the future because what we know about the past. And it's then a vehicle for us to work better or understand better what is going to happen in many areas. Yeah. Okay, a bit small facts here. So we ended up with 380 petaflop for those who can relate to that number. It's a huge amount of computing power. That's what I tried to say, but it's quite compact. So it's not more than about 2 tennis courts in size. Yeah. And that also, but due to the fact that it's compact, it is also gets very hot. And well, I will come back to this, what it means. The areas that it's used for, been talking to. Okay, this is a bit of an interesting picture. This is a heat map of the top 500 supercomputers in the world that are known. So the size, the area of each rectangle here is proportional to the this peak or the performance of each of these machines. So, and the green here, that is US machines. The red is European machines. The blue here is Asia, and then we have Africa and Oceania there in orange. So, you have number 1 in the US. That's the first exascale machine, same technology as number 5, LUMI. When LUMI was introduced in the autumn 22, it was number 3. Then it was Frontier number 1, Fugaku number 3, and Fugaku number 2, and LUMI number 3. And now we have been pushed back here by 2 new. So this is another Department of Energy machine in Argonne that is under installation. I mean, they will grow to be twice as big to this as this one if plans are, it's working out for them. Well, this is a Microsoft machine, commercial. You can guess what they are using that for. And then we have still the Fugaku, which is a bit of a phenomena as a supercomputer. That's own construction from. But what I really want to tell here is to give you a feeling for that this few, the very largest machine, they are much larger than the rest of the pack. Yeah? And that is a development that is going on all the time. You could take another one that is pretty large, Summit. It has been number 1 at one point. Yeah? It's still there. But this is a development that is continuously pushed. And I say Aurora here, the plan there, it's getting it to 2 exaflop, and it will be twice as big as this one. Which is quite an achievement if they do it. Yeah? So, the point here is that the largest machines and why they are so attractive for researchers is that they are so much larger than what you usually can get. Even in the, if you go down on the below top 10 in the top 500, yeah, just below there. So there we are. But it also means that running and operating any of these systems, it's not a walk in the park. It is not that you buy a key-ready system and turn it on and then, okay, now we should, everything should be fine. There is a number of issues. And of course, one thing is that none of these machines is one homogeneous monolithic thing. Yeah? LUMI is definitely not. It is a number of partitions, some people call it modules, but we refer to it as partition. And in LUMI, we have the big performance partition, that is the graphical processing units. And that is where all the performance is achieved, yeah? 380 petaflop here. There is a more traditional CPU partition that is quite small, But with small we mean that it's over 262,000 cores, yeah. So by any national means, it's not small, but it's still compared with the G partition there. And then you have various. There is also a data analytics partition for pre and post processing. Then you have various storage solutions. And you have also down here that only the front row can see, it's LUMI Q, the quantum computing. And an object store and container cloud services. So all these things are there to meet all the different needs we see in modern computing. That complex workloads, ability to share data that you have produced with the rest of the world, with your colleagues and so on. And this forms, all these different parts have their own, so to say, part in the ecosystem. And if we look first at the quantum, which was this LUMI Q, now you can see it there. I think that this is also that what comes with a large infrastructure, that you have to put effort in to push and participate in the development of the whole area. Yeah? So when we now have these machines in Europe, we even more than before have to contribute to the global development of high-performance computing and where it is going. And quantum computing is one of these things. And with the program now, with the number of investments here from the joint undertaking in quantum computers, really put them in place, different technologies, as we heard yesterday, number of different technologies. That will be one of these things that will start a lot of work and thinking and push this area. And here I would say we are really leading this in Europe. So that's very interesting. The other part, and sorry for a lot of numbers on this, but I couldn't resist. So when I say that running a system, operating a system like LUMI is not a walk in the park, because as supercomputers, it is many layers of complexity. When you think you have solved one thing, there is another thing that pops up. And why is it so? So if you go look down here, so this is the LUMI G, the GPU partition. So there are 2,978 compute nodes. And each node, and this box here is a node. What's in the box, in the node? It is one ordinary core there, or a 64 core. It's a CPU, 64 CPU core there that, so to say, run the system, a lot of memory. But the workhorse are these GPU modules. So there are 4 GPU modules. Each of them contain 2 GPU dies, you could say, or cores. People prefer to use the name die here. So there are 4 of them. In total, 4 times 2, so 8 of these in each module. Each of these nodes have 4 connectors out to a switch. So they, in each of them, go to a different switch. These switches are in grouped together. There are 31 of them together. And I try to picture this here in these groups. So one of these boxes here is one switch group, or one switch. And this is just a schematic picture because it is worse. Here you see 6 groups, but LUMI has 24 of these groups, each of them with 124 nodes connected. Yeah? And they are connected all to all. And then all these different groups are also connected all to all. Here it looks like it's one cable, but it's a large number of cables there between them, all these 24 groups there. So for you who want to do the math, you can calculate backwards there and you get to 2,978 compute nodes. So in this system, there are a lot of things that can go wrong, of course, and to be understood. And all the cabling and all the electrical problems and the cooling that is needed here to get this, keep this working, it is another issue. So, sorry for all the numbers, but just to give you a feeling for the complexity and why things might not always be running all the time perfectly. And then we come to the next thing, the cooling. How to cool such a system. We are, when in peak performance here, it is about 8 megawatt that you need to get rid of. So what we do, we have the HPC load. It's a direct liquid cooling. And the normal way of doing this, it's you get the heat into, there is a closed system, you have heat exchangers, you bring it to dry air cooling, which we can use in Kajaani because of the conditions are such favorable, so all the year round we can just do dry air cooling. And then you get colder back here, you have heat exchanger, you can, so the 32-degree water comes back into the system. And that doesn't sound cool, but it's this way, the way you more efficient way you can cool the system. What we have done in Kajaani is that we actually deliver a lot of the heat to district heating. So we reuse a lot of this heat that we generate for heating in the district, in the area, and in the business park where we are, and in the households of Kajaani. But for that, you need also to have heat pumps, because the heat that we get up, this 44 degrees water, is not enough to heat households, of course. So we need to bring this up to 80 degrees to satisfy the company that is taking care of this heat. Yeah? And for that, you need heat pumps, and you also need to put some energy there, although they are extremely efficient. And then you get also to get this 58 degrees water we get there, we use that to bring the other one up and then bring it down to the 32 degrees that we need. But what this means is that you need to have a business model before you make these investments, yeah? Because you have extra heat pumps here, all these things. It's of course cost something to get it there. So from the beginning, you must make a business model that what you can, so to say, sell your heat, you must gain over the total cost here of the machine, that it actually is of value for you. Except, of course, the sustainability thing that we can reduce, because the city here, they are using burning oil otherwise to heat they are getting away from that now, but they used to use a lot of oil just to heat the city. But so I emphasize here the business model. And maybe the important, most interesting number here, and that is the ERF, the energy reuse factor. And it is actually 57% in last year. So 50% of the energy that we push in to use to run the system, we could reuse for heating. So it's not much energy that actually is needed to multiply the floating point numbers. Yeah. It is most of it usually goes away in heat. But if you can make use of that, and I think this is one way, and that is also an area that is where innovation is needed. How can we better make use of this waste heat in not only in data centers but also in other industry, of course, because many have this problem. Okay, I should finish here, I understand. Just to give you a feeling of the data center. There is, that's how it looks. I mean, we have built it inside the big previous machine hall with a floor here, raised floor with technology and everything, so different layers. Some of you have been there for sure and seen it. It also next level of complexity is the network. that is needed. You need to network this with the rest of the world to make it usable. It is an international and globally used infrastructure, so it needs to be well connected. I wanted to say something about the timeline. In March 2019, we had the deadline for EuroHPC pre-exascale call. We got the final configuration here now and started full operation in beginning of last year, where we also later got the full system accepted. So it takes time. Some of this was, of course, we had some other global events here called COVID-19 and so on. But one should also think about this when planning for the future here. So we are not in Europe here dragging this timeline too much before we get the next generation of systems and so on. And also keep focus now, because we are on a very nice path here. So we are committed to run LUMI here into 2027, and after that we will see. But earlier here in March, the Finnish Finance Ministry, Finance Committee sent out a press release that they have committed 250 million euro for a continuation or a future system. So there is hope for this. The usage just of today or yesterday actually, this year 3,462 users have consumed over 45 million GPU hours, over 1 million CPU hours, and 747,207 quantum processor unit seconds. So just to emphasize that this is used also. Something I want to just quickly, if you allow me to draft over here. But users, that's the next layer of complexity, because they come in many different flavors, if I may say so. And there are different expectations on what is an efficient use of such a machine. How do they make use of it? So you can go to the ordinary command line interface. Below this message of today, you get the command line, and you have to know your Unix and all the commands and everything. That is preferred and the use of many of the researchers. But many also want a web interface. And that we now have for LUMI, where you actually go to the web. You can get your home directory, look into that. You can open the Jupyter Notebook. And what is popular also, just to open the command line window there, but then all this hassle with SSH keys and so on is gone, because here you have logged in with your federated identity, what you have from your university or My Access ID. You can have various applications here. If you're AA, you get your Tensor board, Julia, Jupyter, and more applications will come there. So that is something that is important to offer for the general use. Okay, I have to end here, and we can say, and I think it's understood why we are there, to benefit society at large and enable research and scientific breakthroughs. Okay, thank you.
Thank you very much for the inspiring presentation. Are there any quick questions from the auditorium? Yes.
Thank you for interesting presentation. I would like to ask from the other side, personnel, management and experimentators with research and engineering knowledge, these two groups, do you train them? Are they specific, or it's more like on-job training? Thank you.
Well, some of them are here. I don't know what you say, but it's a combination, of course. I mean, it takes many years to build up the competence, and if you go into application areas and so on, and we have collaborated a lot with the universities and also have a number of experts with the background in research at CSC for different application areas. We support that people, when they get an opportunity, can go back for a sabbatical in the university and so to say, refresh and get some research experience again, and then come back to CSC. We have an extensive trainee program where we take in a large number of trainees every summer. University, typically they're around master students and so on, and some of them, of course, in these areas, and some of them they continue work with us and so on. So it is a yes, you must make sure that you have a build up an environment that is attractive, and a system like LUMI helps a lot with that to make it attractive for young people that are interested in these things.
Quick question then, yes.
Thank you for the impressive talk, and I wanted to ask about the dilemma of an HPC cluster. If it is almost full, then users are not happy because they need to wait in line, but if it is not full, if it's partly empty, then it's like not using available machines. So how do you solve this dilemma, and how large is the business of your cluster? How many % on average is working, and how many is idle of the resources?
So yes, how to allocate time and work the queues, it's an art in itself. So you have to design queue systems and so on. So there are different queues for different purposes, and work with that. I can say the system is now as fully used as it can be, with any reasonable, as you say, queue times and so on. We have what you do when you allocate. You do like the airlines. You overbook. Because sometimes you get people, they are not starting when they should, or when they planned, it's delayed, or they are not using the time at all. And what we have been forced to do, that we have actually reduced this overbooking factor somewhat, because the system has been too full. And this is, of course, a thing that always comes up. The queue is so long, I have to wait so long. Okay, but that's a choice you have to. It is not, if you are have a big investor or so that can buy you this kind of machine for your research. Yes, I'm very happy to hear if you are so successful. But I mean, it is something. This is very expensive. I mean, LUMI itself, total cost of ownership, it is above 202 million euro investment. So it is a large money that goes into this, and so it need to be a shared resource. And this kind of way of doing it is the best way we have, I would say, with organizing this. But it is a tuning all the time, because there is always different wishes how it should work and how it should be better. And well, through all my years with HPC, I always sometimes have got this call. I must run now because I have the last thing for my thesis. So there is a deadline, and all the conference is coming up. I need to get my job through now. I need to do it. Yeah. Yes. Let's see what we can do. But of course, you try to help people when these situations are there. But it is, in that sense, it needs to be a bit of democracy there.
Thank you very much. Let's give some applause. And let's continue with our panel discussion that we will have on the future of HPC in 3 Baltic countries. And I would like to welcome the moderator of the session, Thor Wikfeldt from Sweden.
Hello, good morning everyone. Thank you for the invitation to be here and moderate this session. Great opportunity and experience for me. So you saw me yesterday. I lead the National Competence Centre in HPC in Sweden, ENCCS. But it's not about me, it's about people from around the Baltic area and 2 Nordic countries as well, Denmark and Finland today. So I would first want to introduce Ivar Koppel to the stage, who will be our first speaker for a short talk here. Ivar is the CEO of the Estonian Scientific Compute Infrastructure. He's also the chairman of the NAIC board and vice chair of the ESFRI work group for data and digital infrastructures. So please, I think you have, what, 10 minutes or so?
Yeah.
Yeah.
Hello. Okay, so this seems again my old boring slides that yesterday I already talked about, and as the audience is the same, so I'll quickly try to go over them. Okay, so METAIS is a consortium of Estonian free universities, and the reason to do it was that HPC is very scalable thing, and the competencies take a long way to develop. And if we allow everybody to process their own infrastructure, then there have been use cases. So people wanted to buy a storage. I think it cost 200K at the time. And okay, we persuaded them to use our infrastructure. And after 3 years, they had they brought 3,000 euros to us. They had used, I think, 10 terabytes of storage. And I remind you, the original cost was 200K. Okay, that's sharing the infrastructure, so it will be optimally used. Okay, so everybody in Estonia uses us. We have a biobank, which is our main user. I think about 30% of our usage. They are doing personal medicine. Then there is NICPB, which is doing CERN stuff. Basically, when Collider in Switzerland works, and data goes to Estonia, and papers come out of another end. And okay. The Department of Computer Science is a big user. And actually, yesterday we were talking about investments in HPC. So we are so integrated with the university, so we don't think that all kind of EU IA research or whatever kind of computer science is customers. So they are just the guys down in the corridor who are using our stuff, and they are teaching users to data science and AI and okay, so it's the original part of the work. Okay, of course, chemists and NLP, so language guys are main users of LUMI at the moment. And all kind of consortia, plus we are doing very hard work to get private guys to use us. Okay, so I actually don't like to talk about how many cores we have, or I think we have enough. So currently it's utilized about 75%, plus we have LUMI, which is maybe 10% of our Estonian CPU resource, and it's 5 times our GPU resource. So if somebody wants to use GPUs, then we send him to LUMI, and if it's sensitive, then we keep it local. Okay, and yeah, so Estonia is really small. So we have 1 million people or so, and so it means we don't have enough money for proper HPCs. That means we have to cooperate. So we are doing collaboration with NAIC. Everybody knows Puhuri by today, I think. HELSA is about sharing medical data. Nordic West is access to quantum computer. And we also took part of EuroFP tender. And locally we have a system for processing sensitive data, which is a nice machine where everything is logged and you can move anything without approval, and if logging doesn't work, the machine shuts down. And we have some twinnings via Bank, we have some center of excellence, and we have a ongoing agreement with government cloud. That means when Estonian public sector wants to use us, they don't have to have a separate tender, they can directly order it. And our key to success is flexibility. So if they want something, it takes us 2 weeks to get some A100s to make them available, and they can start using it. So if you know how government bureaucracy works, and it's lightning fast. Okay, and in European scale, okay, we are developing something for Enlight, which is about student mobility and united curricula and etc. LUMI, of course, soccer is cybersecurity thing, because cybersecurity is important nowadays, unless you want to get unpleasantly surprised. And some DTs and etc. Okay, so future. So what I have always preaching is that HPC needs to be a bit ahead of their users. So we are enlarging our capability for secure data handling. So now our SAPU is limited to 1 machine, and okay, you can make very large virtual machines, but it's still 1 machine. So now we are developing a secure cluster. Still biobank, so it's something that came out of HELSA project plus 1 million genomes project. AI is upcoming, government cloud, and yeah, so if the users want to do secret stuff, then we have to be ready. So we are currently screening all our sysadmins and preparing to be able to handle even state secrets. And yeah, so on the European scale, we are currently searching money for next LUMI, and I think we have almost succeeded. Okay, so everything I already said. So okay, next presenter.
Thank you very much, Ivar. I would like to welcome on stage now Lauris Cikovskis. Apologies, I won't even try again. So Lauris is an HPC high-performance computing expert with more than 10 years of experience in this field. He currently leads the HPC team at the Riga Technical University, where they provide services to Latvian academic institutions and industry.
Yeah, good morning, everyone. Yeah, thank you for introducing me. I will not repeat. My task is to give some insight what we are doing in Latvia. I do not promise that I know everything. We live even in small country, we live in different information bubbles. So I will speak mostly about my bubble. Yesterday you already heard from our representative from government what we are doing. I will give more technical dimension to this. We do not have that kind of collaboration Estonians talked about ETAs, but we have an official one, which is mostly project-based. How we self-organize to build something together. And the core of this HPC net collaboration, we are 2 biggest universities in Latvia, Riga Technical and Latvian University, And from our side, it's our HPC center, and on their side, it's Institute of Numerical Modeling. Yeah? And in 2019, we decided that we need to do something together in Latvia. Yeah? And then started this HPC net collaboration. And the first project we had together is this EuroCC Competence Center, who is one of organizers also of this event. And yeah, and later came additional projects. For example, yesterday was mentioned that we need to teach 2,000 new specialists on HPC in Latvia in next few years. So there we invited also Riga Stradiņš University, which is the third largest university in our country. And now we are working on 34 study courses to improve together. And we have one other collaboration. Latvia became member of CERN recently, and one of our commitments was to provide also computing infrastructure for CERN. Yeah, and here we are building this in federated way. We combine together resources from several places, institutes and universities in Latvia to provide it for CERN. And we have also other players. Maybe we do not have right now projects with them, but we are looking forward also to invite them as to the same table. And yeah, we call this information network in Latvia, that we invite every stakeholder to understand what's going on and share information. And yeah, if you ask me how much computing power we have in Latvia, I do not have answer. We need to first to bring everyone together and gather this information. Yeah? I can answer maybe only about RTU. Some other activities. Recently was established a shared service center, or we call VPC. Yesterday there was Mr. Grevinch here, also on panel discussion from this center. They are mostly doing all EOSC activities right now. They are representing Latvia in different EOSC organizations. And they provide shared databases, shared storage for needs of Latvian academic users. In 2015, we got a data center which is located here in Kīpsala, but it's not RTU data center. It is run by our Ministry of Education and Science. And all Latvian academic institutions were invited to put their server equipment there. Also RTU HPC is located. Our supercomputer is in this data center. A Latvian university cluster is there. So we use shared data center in Latvia. And one other interesting initiative recently, there was involved private companies from Latvia, Mikrotik, which is network equipment producer, and also our mobile operator. They created alternative academic network for genomic use cases, so that we could transfer big genomes between institutes who produce this data and HPC facility where they can analyze this data. And a week ago there was also announcement that in this network we have test connection between data center here and data center at Mikrotik company at 400 gigabit per second to start using also network at such speeds. We are also doing things in improving user experience for HPC. This picture is quite complicated. I will not go in much detail, but the main thing is this middle layer between HPC and our users, where we try to offer different tools in similar way as Öster showed for LUMI, that there is nice interface where you can select by Jupyter or some other services. Yeah, there is also Valdur, which is, I think, has become a standard for Baltics, and not only for Baltics. And how HPC is used in Latvia. Unfortunately, I have data only from RTU supercomputers, so I know there are some other fields that are not mentioned here, but this picture reflects much of our country usage. As you see, bioinformatics and genomics is field which is there are coming most users. Also computer science, as in every country, artificial intelligence, computational chemistry, and right now high energy physics is at very low level, but when our tier 2 is operational, then of course this number for CERN activities will be much higher. Some challenges, and I believe these challenges are the same for many countries, and lack of skills. Many companies, industry, and also academic users, they even don't know about supercomputers, and this is how, what we are doing through our competence center to try to educate them and bring this information to them. And I think we do not use full potential what HPC can give to Latvian science. We can do more. Also, a long-term development plan is needed at national level. It would be much easier. I do not blame anyone not having this plan, then I should blame myself as well, that we do not have such plan. And these two problems leads to third one. We need highly skilled professionals who can work on HPC. Currently, we invite IT people to our team and then teach them what is HPC. And last slide, and I wrote this before yesterday. Our moderator sent his questions, but we do not need to answer this. I just bring them here, that what we should think about. I do not have answers to them. Should we host in Baltics EuroHPC supercomputer? Maybe. Maybe not. Maybe we can use LUMI and it's okay. Joint study programs. I know that Estonia is developing courses on HPC. We are doing the same in Latvia. Would be interesting to hear what Lithuanians are doing. Maybe we can do something together. What are HPC interactions with quantum computing initiatives in Baltics? And any other ideas? I found some photos for recent collaboration events. Unfortunately, I couldn't find with Lithuanians, so we need to make photo today. Thank you. That was my last slide.
Thank you very much. Interesting talk, and your invitation to Lithuania to collaborate segues nicely to the next talk, which is by Mindaugas Macernis from Lithuania. Welcome. So Mindaugas is a leading physicist, professor of physics, and head of the HPC laboratory at Vilnius University. He's been involved in many projects, the Lithuanian Grid HPC network, EuroCC 1, EuroCC 2, and so on. So he'll hopefully share interesting insights into the HPC ecosystem in Lithuania.
Hello. Thank you for ability to talk. I will present about current situation in Lithuania, and mainly the one word would be that it is like a virtual organization for HPC. Because supercomputer is located in Vilnius University, and the Vilnius University strategy is scientific university, so there are no laboratories, only professors with their equipments. So similar is organized all the activities which are related with HPC. So I divided into several parts how this organization is established. It is one part hardware, which in Lithuania is located in Vilnius University as supercomputer, VU HPC. Then there are 2 open access centers for services. Of course, there needs people and collaborations or projects. So we are thankful for EuroHPC, EGA Federation, and companies which involves in this activity. And of course, they need some competences, and the competences are related to software and scientific groups. About infrastructure, hardware. So hardware is in two places which are connected by dedicated line. And depending on the task, it can be run on one or another side. Mainly, the main difference is that one side in mathematics informatics faculty is more GPU-based system, while in physics faculty is more CPU-based system. Both places have official look from outside to access, and there are two open access centers. Mainly they are due to not for computing time giving, but for services which are needed from scientific groups. In one side is operated as Open Access Center HPC Saulėtekis, and there are scientific groups who can help in from installation of high performance software to expertise in HPC development up to quantum computations, quantum chemistry, molecular dynamics. So such services are provided, and companies can access, outside scientific groups can ask for such tasks. In another open access center, there are more informatics-based services, which are data analysis, algorithms, blockchains, census protocols, and many others. Here's the list. I will not read them. All the activities are over many projects. There are EDIG initiatives, EDIG Vilnius, where companies can get resources for HPC computations. Then EuroHPC National Competence Centres, where we provide competences. Also EGI Federation from Lithuanian Council, Research Council. There are projects which helps to operate all the system. Many collaborations that we gather competences, and from Red Hat, MATLAB Academia, various memberships, which helps to have more knowledge and give some competences. So the competence center gather Lithuanian knowledges, and if the first stage was only Vilnius University with two main these parts, where is HPC competences, now we have 5 partners from Vilnius Tech University, Kaunas Technological University, and Lithuanian Hydrometallurgy Council. So these partners has knowledge in HPC, and over this project we can collaborate and exchange provide knowledge. Also, we are thankful for AGA Federation, which helps us to get some financing and actively involve some projects and supports our HPC infrastructure through its membership activities. As I mentioned, it's the main thing is to have people who has knowledge. So there are many commercial software which are installed in the infrastructure, and people who can deliver knowledge, competence, and experience how fast to run and achieve the best results. Because we rely on scientific activities, and we always expect that companies also come not for computing time, but for scientific problems which can be solved. Here's some slides about achieved some benchmarks. It's also quantum computer simulators, quantum chemistry. One of the research group who actively has collaborations with other universities and develop own packages for the running on HPC systems. So that's it. What about our current situation? And thanks.
Thank you very much, Mindaugas, and I would like to welcome all the speakers from the session and also ask for help to bring in 5 seats. So please welcome back on stage Per Öster, Mindaugas, Ivar, Koppel, Lauris, Cikovskis, and in addition, Eske Christiansen. Okay, so this was highly interesting. Thanks a lot for your talks here. One person in the panel has not introduced himself yet, so maybe you get a brief introduction. Where are you coming from?
Yes, my name is Eske Christiansen. I'm coming from DK, that is the Danish e-infrastructure collaboration. I'm head of HPC department there.
Thank you. So we have the Baltic countries, we have Finland, we have Denmark. What did we hear today? I liked your reference to the HPC ecosystem. I'm not a biologist, so I'm not offended by that term. And I like to see it as a combination of the resources, the infrastructures, but also the people and the skills. And I think we heard a recurrent theme in your presentations was skills, the lack of skills, and I guess that can be on both sides. So lack of skills among the users. If HPC is a Formula 1 car, then we probably have users coming in without a driving license, but also lack of skills among when you're recruiting. You know, it's difficult to find the relevant skills for application expertise in HPC. So maybe we start there. How easy or how difficult is it to recruit people when you're in need of expansion? Ivar.
Yeah, so personally I have zero expectation for new people, so I expect that we have to train them about a year or half a year in a better case. But it's okay. So.
Yeah. Same for you, Mindaugas?
Well, we are based on university. There are students, so mainly if we need new HPC experts, we start from them to educate and involve as fast as they can. It of course depends on people.
Yeah.
No, yes, as I already mentioned, it's very difficult to find highly skilled HPC experts. It's easy to find students who study IT, also researchers we can involve, but we have to teach them at our center.
So switching maybe to Denmark, how does it look?
It is very hard to recruit. So we have taking a route this time where we are trying to search for software developers, highly skilled software developers, and then train them into what we need, because we cannot hire any AI machine learning experts at the moment because they all work in the private industry. So, but we, at the last round where we have 43 applicants for our 3 positions that we are trying to have interviews with now, and we can see there are some of the skills we need, but we need to educate them for the last push. So with writing good job description, we can actually get the people that we want.
Yes, it's an art to write a good job description, yeah, to attract the right crowd. So the situation must be entirely different in Finland, considering LUMI, size of CEC, and so on. And you already mentioned this traineeship program. So do you think you have any lessons learned from your efforts to train people that could be transferable to other centers around the Baltics and Nordics?
Yeah, I mentioned the trainee program, and it has turned out to be a very important factor for us, because you get in touch with young students while they are in their studies. They might get an idea for a master thesis or so, and then even if they just work for us a couple of months over the summer and into the autumn, yes, you have contact with them, and they might come back if they find. And of course, one has also have to prepare. If you hire young people, they might stay for 2-3 years, and then want to go somewhere else and try. I mean, you get curious. You get to build up your network while you're working at a place like CSC, and get contacts and move somewhere. But what we see is that after 5 years or so, some people they come back and start to ask, "Do you have something for me now? This is interesting. I've learned this." And so we have a number of these people coming backers, let's say that, and that is you have to create and maintain, try to be attractive for them.
One of the things that we learned is that we have to look at other thing than the paycheck. We have to look on what they can work with, who they can work with, and that is a big selling point for us, that they get into helping the researchers achieve their goal, and in that way learning something and taking that into themselves and be better at what they do. And so our motto is, at least in my department, that you have to be smarter every day. So every day you have to learn something new, and that is what we try to drive in our department.
Yeah, we need to offer different benefits than industry, because industry always has higher salaries, and we need to find benefits to our team, maybe more flexible work time, not so tough deadlines for works. Yeah, then we can compete.
So there are these undefined roles in academia. They're getting better defined over time. I'm talking about research software engineers, people that come for the science, do a PhD, but they're mostly interested in the tooling, the coding. They come for the science and stay for the technology, right? And I think this group of people are underappreciated. They don't get as many academic papers as others, but they write a lot more code, and they get publish a lot more on GitHub and so on. So this might be an underutilized resource, or a natural resource to tap into for HPC centers. Do you have any communities of such research software engineers, technical people in academia? So there are international initiatives. It all started in the UK, I believe, and then there's a Nordic research software engineering community, which is rather active. So does this sound relevant, interesting to your centers?
I can say only, of course, it sounds interesting, but no examples are coming to my mind right now.
Actually the same, yeah, so definitely interesting, but we have no direct contact. So okay, nowadays, at least the university sees a different career path. So under HPC you can advance even if you are not doing any papers and publishing them.
Well, I think it depends, because I once had a talk with one theoretical physicist. He said, for me it's enough pencil. So, but if there are some researchers when they need support from HPC, they cannot get projects, and this is the way where this HPC infrastructure can help. That in order to publish a paper, they need HPC resources to work. So I think in laboratory also some people sit for several days or weeks to do experiment and then to make a paper, and it depends on what the research is. So.
Yeah, indeed.
I would. I mean, it's very important that to be attractive, you have to give opportunities here for people that come in to participate either in networks that they are already in from their expertise when they come, or that they can see that with your organization they can build up networks and find colleagues around. I mean, you mentioned software development, this kind of code refinery initiative and things like this. It's very important to allow people to have some time to spend and get engaged in these, build up the networks. And I also say here that the Horizon Europe projects and so on, they are very important here also for getting people involved in and build up their international networking and work with colleagues in other countries and so on. It's so to say, it is rewarding for most people to do that, and that's an important factor. And we use it very much for our R&D. That's how we develop our services, basically. So that is necessary activity.
We have a structure where we are trying to bring all the developers and the people at the universities together for 4 or 5 times a year, exactly to do all the networking, because they are sitting singularly out of the universities, and we want to bring the knowledge together and so they have a feeling of they have some colleagues at the other universities that can call if they have problems and stuff like that. So we support this kind of knowledge sharing locally.
Sounds great, and I'm also happy that Codefining was brought up, because that's indeed a Nordic plus Baltic community of technical people. They love technology. Many of them come from HPC, so probably we should look more in that direction. I mean, there's already a chat with 500, 600, 700 people signed up to the chat platform. So for job announcements, I think that could be a good platform. So, but I would like to open up the possibility for anyone in the audience to ask a question. Yep.
Yeah. How would you assess an opportunity to implement secondment or exchange program with Nordic American or Asian HPC centers? Is it maybe it's already happening? Thank you.
To some extent, at least for us, it's already happening. We recently had a guy from Texas Advanced Computing Center for a couple of weeks. If it was a month, somebody might know, a month visit. Yeah. To us, and now we're considering who can go there for, and how do we. But it is of course also a bit of a cost. How do you cover the cost and so on? What are the things that you have to cover? Because, and we have someone right now that is at CSCS in Switzerland in this kind of exchange. And so this is something we try to do when we find an opportunity and a partner where we have similar technology. But I mean, there are several things you have to resolve with this. I mean, how do you do with all human employment issues and so on that you have to figure out with them. So it's not just okay, let's do it, but it is.
Okay, in this sense we are quite local, so I think we have some, our first employee lives and works from Norway, but no obvious US connections. Okay, my head of support is dual Estonian US citizen, but that's it.
In Lithuania, maybe more complicated. As I said, our HPC is like virtual organization, so it mainly depends on the group if there are some collaboration. So only in this way.
We haven't had such experience, but yeah, we would be interesting. But then we need project, because for the core team who is providing HPC service, we are looking for long-term collaborations with people that if we teach them, we spend year, 2, 3 years to teach them. Yeah. And for projects, it's different. Then I think it's possible to have person exchange for few years.
Mm-hmm. Okay, so we've talked about upskilling, reskilling in order to grow our staff, to have people working with HPC. But what about on the other side, on the user side, training to users? People come in to HPC centers, they might not know much. I mean, they don't have a driving license to drive a Formula 1 car. What type of training offering do you have? And do you see a value in sort of collaborating more on training, giving joint, I don't know, summer schools? So maybe we can start with the Baltic countries here.
Okay, we do it all the time and with all kind of granularity. So first we have HPC courses in the university. Then of course we participate wherever there is some EuroCC or PRACE or whatever might be interesting course. And at the other end, if there is some interest from industry or some group of users, then we go and make a private training, so just we could use our services.
Well, we are thankful for EuroCC project. It helps to have regular trainings for users. It is very important, and of course, several layers of training. Some HPC is integrated in curricula in the physics faculty, in mathematics, informatics faculties. So the students who are interested are educated. Then scientific groups who imagine that if there's more computing power, the software will run faster. It's not true, and we provide training for them, for those at first who understand it. Then the next step is that administrators see if the user uses more computing time. Then we ask to provide a seminar or some explanations. And typically we see that they need trainings, and we talk with them that we will train you. And after the training, they are thankful that they understood why they could use 100 times less computing power to get the same results. So this is success stories, such, but mainly at this moment, we from Competence Center is organized more these trainings.
I think we should distinguish two groups of those who need this training. One group is who don't know about HPC, and they don't know even if they need this HPC. And then this is a study process of university when we show every student that there are HPC possible, but maybe they will use in future. This is investment in future. And other group is, of course, those who already understood they cannot do something on their personal computer, and they come to HPC center and ask for help. And then, of course, we have procedure how we work with those new users, what we teach to them, how we demonstrate. And of course, competence center is also very important here, because maybe they are more helping this first group I mentioned, for those who maybe need, maybe do not need HPC. Yeah. So we have different
So, so in DAC we don't have any training or any education as such, because we depend on the universities to actually have the training and the education for their own employees, and then they should know in how to use HPC. With that said, that we as a goal in DAC have to enable HPC for every users and for all science directions, so that includes the social science and the humanities, as long as with the normal STEM science. So, and we can, and with that we need to have a system that supports the full range, from the cloud-based interactive HPC to the full-blown EuroCC queuing-based system like LUMI and Leonardo and stuff like that. So, and we can see that there's a big success in doing this, with enabling the social science and the humanities with just a single instance VM, and they can train and see how it figures, and then they discover how they can do. When they hit the limit with the cloud, they say, okay, can we do more? And then we can train them with a little bit with how the queuing systems works, and then they actually develop their science and their own education. That is one of our goals.
Yeah, that was one of my questions in my presentation. Should we do something together also? I remember we had together a student cluster competition team in 2019, maybe. Yeah, maybe we should again build team of with representative students from every Baltic country.
Why not? Have some leading students.
We could find few.
Sounds like an excellent investment of time and effort in the future. How about from CEC? I mean, I know you already have advanced training material, training schedule, training program.
Yeah, we have a lot of training. I mean, since many years, it must have been, what could have been, 2008 or so, we organized this summer school in HPC. That's been going on, and I saw earlier this month it was at least some seat available still for this summer, so you can still apply, I think. So that is one thing, but then also, I mean, this regular training events during the year, but that is also a benefit with the LUMI consortium. I mean, we can benefit from each other's training, advertise it to our users. There is some training going on here in some other country, and then one can advertise it to all users, and maybe they are online trainings or they are on site and so on. That depends. So that is another benefit with the consortium. Because this is necessary. I mean, this kind of skills transfer that people doesn't get in the university training, that we can provide. I mean, how you actually make use of a system. Just how do you work with the Linux system and get something done there? That kind of training we have had for a long time. I mean, it doesn't need to be about HPC, but then of course there also this more advanced training concerning certain applications and so on that are regularly there. But they are open for anyone basically to join. Yeah, so that's it work, and then a lot of material on the web also, so that is important for. But I like the idea of a student team here. We are just now, we have a team in training from Finland for the cluster competition there in ISC, I think so. That's and yes, the trainer is here.
Do we have another question from the audience? Yes. Thanks. I'll keep it on.
Hello. Hi. So I was just wondering, what are your relations with intellectual property or a share in the property, or do you see yourself just servicing the ones who own it, or and what's your maybe strategy on this, or do you have any? So maybe a comment on this. Thank you.
Interesting. Wait, you must clarify what you. So, intellectual property in what sense? When it comes to training material specifically, or
training maybe could be one aspect of it. I'm just thinking of the income stream. I mean, do you participate, or do you see yourself participating in a project where intellectual property is created, and then you benefit from it, like a license from it, or I don't know, do you maybe invest in being a shareholder as a center in a startup company? Is it even possible? So, like, what's your relation to it?
I can answer from. Then I have to answer from a CSC point of view. That is, this is not a one of our, so to say, business streams to protect. We do protect our intellectual property. We have some open source software that we develop and we put in. It is out in open source, but as we have the also say the IP owners, we can also release it under other licenses. And so during my times, it happens that we get requests for this for some commercial party that want to use the software for commercial properties and want to buy it from us. And we have had such discussions. I have had some, but I must say it has never resulted in anything. But it is an aspect that sometimes, of course, need to be taken into account, especially when we work with industry partners within the European projects and so on. It's always, so to say, stated what is the background you put into the project, what do you do with IP that is developed together, and so on. So these matters are always there, although it's not a, so to say, particular business for us, but it need to be taken care of. That is for sure.
Okay, for us, what we are developing is usually open source, and so it's intellectual property is not such a big deal for us, but still, if you ask where we are growing, then it's soft skills, so GDPR specialist, property lawyers, etc. So.
Well, in Lithuania, we are located in university, so everything is regulated by university, intellectual property, and of course, the scientists who do research, they are the owners, and they only can acknowledgement or somehow help to survive HPC hardware, but. Everything is regulated by university, and
my answer. You, Per, said it's maybe not your main business. Of it's quite the same. I feel maybe if I look from other side, when there comes company to us and says we want to use your HPC, but we want to defend our intellectual property. So let's make non-disclosure agreement, NDA, and actually I don't like these because we are public funded HPC center. We are having much of equipment coming from European Union and public funds, and that's why I always say you need at least to publish some pictures at the end of what you have done. But there was case when they said you can't even mention our company name. This I don't think is good for university.
But then it sounds like they have to start paying you something for.
No, of course they will. They pay. Yeah. But anyway, I don't think that they should go to Amazon then.
Yeah. Well, yeah. Okay, so I think last topic I wanted to bring up is based on something you took up, Eske, and I've also heard from you mention industry users. We have emerging user groups from the digital humanities, also industry users coming in with large AI use cases that can only run on HPC or for super high costs in the cloud. So that's why HPC might be good for them. They have different needs, different backgrounds. They're not physicists, chemists, computer scientists. There's something else. Their needs differ. They might not know the Unix shell very well. Batch scripts might be super intimidating. So Per, Öster, in CEC, you developed the web interface, which looks very good. I haven't played around with it much, but how much of a game changer is it? Is it used a lot? Is that something you're also looking into in the Baltic states to offer like a cloud-like interface? How important is it?
I can say for our side it's very important. We can see there's a very high influx of users that have never used HPC before and not even considered it. And now they are depending on it more and more because they can see that they can achieve more in their research by having a interactive way where they can just log on the HPC, run the simulation, and then go back to see if they should refit it, and they have a way of working this way and have the computing power for doing this. And then when they're ready, they can move to the bigger system and do the data set and stuff like that. So it's very important also for development of the research. So I think we had over 4,000 new users last year. No, not last year. From 2020, we have 4,000 new users primarily from the humanities and social science, and so it is a big thing. So
that's amazing. How about you guys here?
I already showed slide that we are also thinking of user-friendly interface for HPC. There will always be the users who are okay with command line and they say this is the best way of using HPC. We call them traditional HPC users. But actually we have exhausted number of those traditional now, and now are coming new users from industry field, from students. They don't know Linux command line. And for them, we need something similar to Amazon. Marketplace and nice graphical interface. It is very important.
Well, I had some communication with the people from academia which are not related with computers, but they know what to do if we're looking into their task. It's really is HPC based, but the main problem that they don't know how even computer is working. So yes, there is a problem. I think it's a gap because they cannot be educated for IT field because they do research in their field. They understand it, and yes, it's a problem. It's somehow interdisciplinary should be organized, or HPC centers should have such dedicated people who understand deeply and do all the these things which are not basically related to any personal research. It's just like working for them. But yeah, it's really a problem. But there are something what can be done, but it's not clear how to organize.
Okay, for us it's very similar to CSC, so we use the same open on demand and we are adding applications to it, so people without much skills can use the HPC and familiar apps.
That sounds promising for the future. And we're up on time. Any last comments from you and a statement about the future of HPC in the Baltics or the greater Baltic Nordic area? Great future. Great future. Let's end on a high note. So, big thank you to the 5 panelists.